concept of catapults, but fewer people know the concept of trebuchets. Unlike catapults, trebuchets use a counterweight and a sling to propel projectiles. The purpose of my investigation was to test how, if a trebuchet is set up to launch tennis balls, how it performs under differing circumstances. My problems were, if a trebuchet is set up to fire tennis balls, how will the weight of the tennis ball, the weight of the counterweight, and the angle of the release nail affect how far the ball travels? The counterweight and the ball's weight are fairly self-explanatory, but the release nail angle affects when the pouch releases the ball, so it affects the arc of the ball as it travels through the air. My hypotheses were that medium-weighted balls would conserve more inertia while still being light enough to travel further than light balls and heavier balls, and that the heavy counterweights would give the ball more force and thus make it travel further. I also hypothesized that the nail angled slightly forward would release the ball at the best time. Now for my procedure, first I had to construct the trebuchet. Found the instructions on stormthecastle.com. The trebuchet is 91.44 centimeters long, 30.48 centimeters wide, 58.42 centimeters high, and the swing arm is 101.6 centimeters long. And the way it works, the way it's loaded, is first you take the hook here and attach to this. And currently, for the counterweights, I only have it on 5 pounds. This isn't strong enough to launch anything, so just for demonstration. You unwind the pouch here, then place the ball inside the pouch, then pull it down, and then use this to secure this metal bar to secure the arm in place. Just a second. So then, once everything is secured, and this is pulled out, the ball travels upward, and in a setup with more force, it will come up like this, and at some point this hook will fly off and release the ball, and it will travel that way. For the first portion of my experiment, we tested how the different weights of tennis balls, how far the different weights of tennis balls would travel. I used an unaltered tennis ball, which weighed 56.70 grams, a medium-weighted tennis ball, which weighed 172.93 grams, and a heavy tennis ball, which weighed 286.33 grams. And the way I altered the weight was I cut a hole in these two tennis balls and filled them with BBs to their desired weights. I also stuffed them with cotton balls so the BBs wouldn't roll around inside. My constants for this portion of the experiment were the 99.07 kilograms counterweight and the 105-degree forward nail angle. The variable was the weight of the ball. And the way we measured it was every time a ball was launched from the trebuchet, I would have an assistant mark where it landed. Then we would measure from the front of the trebuchet to where it landed first, where it first touched the ground, not where it rolled to. For each of these balls, we did 5 reps each, with each variable 5 reps each. And for the counterweights portion of the experiment, we tested the trebuchet setup with 6.80 kilograms of counterweight, 9.07 kilograms of counterweight, and 11.34 kilograms of counterweight. And the constants for this portion of the experiment were the 56.70 gram ball and the 105-degree forward nail angle. The variable was, of course, the amount of counterweight, and we gathered the data the same way. For the next portion of my experiment, with the nail angle, we tested it with a 90-degree straight forward nail angle, a 105-degree forward nail angle, and a 115 forward nail angle. And the constants were the ball weights and the counterweights, and the variable was the nail angle. And again, we gathered it in the same way, and for every variable, we tested it with 5 repetitions. For my results are graphed here. For the first portion of the experiment, the 56.70 gram ball averaged at 10.03 meters. The 172.93 gram ball averaged at 10.17 meters. And the 286.33 gram ball averaged at 5.66 meters. And for the second portion of the experiment, seen here, The 6.80 kilogram counterweight averaged at a distance of 8.03 meters. The 9.07 kilogram counterweight averaged at 10.03 meters. And the 11.34 kilogram counterweight averaged at 11.49 meters. And also, the averages for these two are the same because we use the same results for the same two because it's the same setup with the same counterweight and ball weight, nail angle, due to how the constants and variables lined up. For the last portion of the experiment with the nail angle, the 90-degree nail angle's results averaged at 12.63 meters. The 105-degree nail angle averaged at 10.03 meters, and the 115-degree nail angle averaged at 6.38 meters. For my conclusions, my hypothesis about the medium-weighted tennis balls traveling the farthest was partially supported. While the medium-weighted balls averaged higher than the lightweight balls, some of the individual results from the lightweight balls were far farther than any of the medium balls' distances. But the medium-weighted balls results were consistently at about 10 meters, whereas the lightweight balls' results were anywhere from 12 meters to 6 meters. Of course, the heavy-weighted ball performed the least well at the shortest distance. My hypothesis for the second portion of the experiment was supported. The heavier counterweights gave the ball more energy and allowed it to go further. And for the last portion of the experiment, my hypothesis was not supported. The 90-degree straight nail angle threw the ball further than the 105-degree nail angle, which performed second best, and the 115-degree nail angle, which threw the ball straight into the ground. If one were to extend my experiment, we could test how the different variables interact with each other. Also, if one were to do this experiment again, one could possibly use the medium-weighted ball as constant rather than the light one, because its results are more consistent. And the practical applications of my experiment is it's a good demonstration of basic physics principles like torque and inertia. Any questions?
What problems did you run into when you were doing your experiment?
Well, originally we were going to do the experiment with ping pong balls, but those were too small to use properly with the amount of BBs. Any other questions?
If you were to go for even further distances with your trebuchet launch, what lessons have you learned from this that you take forward in building a bigger, probably more long distance launching trebuchet?
Well, you would probably want to build it a little bit bigger, probably, with more counterweight. And also, you would probably want this pouch to be a little bit bigger because it can secure the ball better. And even if you were using a larger type of ammunition, you'd want it proportionally bigger than this one is, because this one was almost too small for our purposes.
Okay.
Anything else?
What would happen if you varied the nail angle to go in like the backwards direction of what you had been doing? You're only varying it off 90 degrees by like going in one direction, right?
Yeah. Yes. If you were to vary it backwards, that may not even be safe because if this was backwards, the nail might not even latch onto there properly, and it might just slip off and not work at all. Possibly if you go a little bit further back than 90 degrees, you might get better results, even better results, or it might start to go back down a little bit, but yeah, it would be interesting. Anything else?